Day 7, no space left on device. It's not terribly surprising by now, but the device given to us by the elves is full of junk. In fact, it's so full of junk that it doesn't have enough space to run its next update. So the task that's set for us is to find all of the directories with size at most 100,000 and then add together the total amount of space taken by those directories. Now this wouldn't be too bad if we had access to the file system, but the elves haven't given that to us. Instead, they've given us a log file from some random elf who took a tour through the file system earlier in the day. Wouldn't it be nice if that elf had just done all of this addition while they were at it? Let's actually imagine what they would have done if they were doing something useful. So they probably wouldn't have cared about all of this directory output because we're going to change into each of those directories anyway. And they also would have been a little bit more careful when they were exploring the file system because we can see that there are 406 total cd commands, but of those there are only 200 cd ... commands, which means that at the end of exploration, the elf didn't fully back out of the directories that they had entered into. Now we're going to go ahead and comment out all of this so that we can consider, as the elf was exploring each directory, what if they had kept track of the size? Now each directory needs to be a self-contained unit, and we can use something like a function definition for that. And when exiting each of the directories, we're going to close off the function definition and call it. Now when we run the auto formatter, we can start to see some of the underlying directory structure that resides in the output from that elf. What they would have done next, I suppose, is upon entering each function, go ahead and just record like, okay, what is the name of that directory? And also let's keep track of the size. We'll start a variable at 0 for that. Now each time we encounter a file that has its size listed, we're going to go ahead and take that and then add it into the size. And we're also going to say for each nested subdirectory, we're going to add the size computed from that into the size of the containing directory as well. Upon exiting a directory, we're going to do a couple things. First, we're going to check to see if the size of that directory is less than our limit, that 100,000 from earlier. And if it is, then we're going to go ahead and print out some information about that directory. So we'll go ahead and print its name, and we'll print its size. And then also, in the case that this is one of those that we were looking for, we're going to go ahead and add into a total the size of that individual directory. Finally, because we want the containing directories to know how big the directory we just left was, we'll go ahead and return the size as well. And a few preliminaries before we run this: our overall size of our file system starts at 0, also the total size of the matched directories, and then the limit we were working with was 100,000. Now we're also going to want to know the size and the total at the end of our program, so we'll go ahead and add in some output statements for those. Now we can run our convenient script that is a recreation of the elves' experience as they were navigating through those directories. We find the total size of matched directories here, and it turns out that in fact that is the solution to the first part of our puzzle. Now for part 2, we need to find a single directory that we can delete to free up enough space, and we'd like to delete the smallest such directory. So let's go back here and compute a few more things. We need to figure out how much free space do we currently have. Well, the overall total space is this 70 million here. And also from our previous run, we found that the total amount of space used was this number. That means that the amount of space we need is going to be not 70,000, but 30,000 was the amount of space for the update. And then we're going to subtract off the amount of free space that we already had. Now if we're looking for files, we want to look for, or looking for directories that is, we want to look for a directory whose size is greater than or equal to the amount that was needed. So we'll make that change, and then we'll run our program again, and we find output of each of the directories that has enough space. We'd like to delete the smallest of these, so let's go ahead and just write up a quick function here that's going to compute the minimum of those, and we'll fire up our interpreter, paste that all in, and we get this number, which turns out to be the size of the smallest directory we can delete, the second puzzle answer.